In a previous lecture, we had discussed how you can approximate nonlinear functions through a set of linear constraint equations. And the basic idea was, let's assume we had some convex function. What we would do is we would support that convex function through a series of tangent lines. And we would use these tangent lines to effectively approximate the function that we had under consideration. And so what we did in the lecture is we demonstrated how we could do that approximation by calculating the slope and intercept of each of these tangent lines, putting them all together where we represent each separable function. So we did that with the variables t1 and t2, which essentially represented a function on x1 and a function on x2. All right, so we ended up, for this particular problem, selecting a set of tangent points, different tangent points for each function, and we calculated our slopes and our intercepts, and we were able to come up with an LP problem. Now, ultimately, what we ended up doing was putting that LP into Cplex and hard coding all the values. Now, at this point, it's worth asking, well, we learned how to do some of this in Excel. Why don't we just load in the Excel values? Okay, so that's what this video is going to focus on today. Now, we had previously calculated these values and saved them to an Excel spreadsheet. And you can see here, I have the values for the tangent lines in two different sheets, for the first function and for the second function. Now, in order to make this useful, what I need to do is actually label these values so that we can just load them in. Okay. So if you recall, the values that we needed are the slopes and the intercepts of each line. So I'll go ahead and name these, and I think I might have already have. So this one's called slope 1, and then we also have intercept 1. Right. Similarly, we can do the same thing here. We'll have slope 2 and intercept 2. At this stage, we need to make sure that we have the file saved in the same location as our workspace. So to do that, we can again right-click on the properties, check here where that location is. If we click this little link, it'll actually take us over. So you can see if you sort of hover over, it says Show in System Explorer. And at this state, we need to sort of save this Excel spreadsheet there. Right, so right now I have this just saved on the desktop. Right, let's see. So I'm going to go ahead and move it from the desktop, or copy it from the desktop into the workspace. And in order to help, I'll sort of name it something else. So we'll call it linapprox. Okay. If we refresh, we should then see our linear approximation. Okay, so we've got that mostly set. And at this stage, what I'm going to do is create a new linear approximation file so that we're using the data instead of hard coding it. So I'm just going to copy the old one into a new file, and we'll start replacing it little by little. So I'll call this linear approx with data. Right, so starts empty. And again, the first thing that I'm going to do is sort of save everything, or copy everything over. Okay. So first thing, we're just going to keep our decision variables the same. All right. So we're going to approximate our convex separable function. So we have two of them with the variables t1 and t2. And then we're solving for the optimal x1 and x2. All right. At this stage, we need to load in the slopes for each of the approximations. So I'll call them, we're going to generate these parameters. Oh, and actually we need to do something else. Why don't we keep track of how many tangent lines we use? Okay. So I'm just going to say ... for the placeholders. All right. We can also, and I'm going to do something a little sneaky. I'm going to create a range called use lines. Okay, so which tangent lines are we going to use? And first we'll just assume that we use n1 tangent lines. And for the second approximation, we'll use all n2 tangent lines. At this point, we need to define our s and our b values. All right, so we're going to define our s and b values. Let me erase that. So we're going to have S1 and S2. So again, these are the slopes for each of the sets of tangent lines, and then we'll have B1 and B2. Okay. Each one of these are going to be vectors, so we can use the ranges. And again, we're going to load this data in from the spreadsheets. All right. Okay, so we've loaded in how many tangent lines we have for each function. We created a range so that we can loop over them. And then we also stored, or will have, the slopes and the intercepts of the tangent lines. So at this point, we can start replacing our constraints. We're still doing a minimization with T1 and T2. But now what we're going to do is we're going to replace all these tangent line equations that sort of form our approximation. Okay. Now the key part here is it's always the general sort of equation is sort of mx plus b is less than or equal to t, all right? And we're going to match this sort of equation. And for the second one, it's going to be t2. All right. So this is the general form. Now we're going to take advantage of the for all and replace all these equations with just two for all loops. Okay, so I'm going to go ahead and delete this. And so first we're going to say, and we can tab it over, for all, let's say L in use lines 1. So here we're going to do the first approximation. All right. And at this point, we can use curly braces. And so what we want to do is we want to say that slope 1 L times x1 plus BL is less than or equal to T1. Right? And so what we've now been able to do is replace all the constraint equations for the first function, or T1, right, with just 3 lines or 2 lines. I mean, those are pretty cool. All right, so we can go ahead and then replicate this same idea for the second set of lines. And, you know, maybe this isn't a good variable, so if you want to, maybe you can call it C line for current line. Again, I would always use good variable names so you can sort of follow along with what you're doing. Or it could be C tangent line, right? It's up to you. Okay. So at this point, we have most of our problem pretty much set, okay? And then the only other thing were the constraints on x1 and x2 that were sort of, appendages to the problem, but they weren't too important. Okay, so now you can see we've made this problem a lot easier, at least in terms of programming up. The only thing that we need to do is actually make our DAP file to load in the values for n1 and n2, and then also the slopes. All right. So at this stage, I'm going to save this guy, and we're going to create a new DAP file. And I'll just call this tangent lines. Right. So it creates this tangent lines.dat. Here in configuration 2, I have the linear approximation model. So I'm going to drag in the mod file for the one we are just working on. Actually, do I need to delete this? Delete that. Okay. And we also need to drag in the data link. Okay, so let's sort of edit this tangent lines file as we need to. So in order to make this a little bit easier, I'm going to actually sort of copy and paste what we had in the Excel file before from the last video, just so I don't have to re-remember what the names of these functions are. Okay. So again, the first thing that we do is we do a sheet connection, and we can call this a sheet connection to tangent lines, and we want to point it to linapprox.xlsx. So that's the file again where we had all the values. We then need to load in the tangent line. So I'm going to delete this because again, this doesn't sort of apply, but we can load in S1 and B1 from our file. And then we need to do the same thing for S2 and T2. Now again, I'm just sort of copying and pasting from an old problem, so I'm going to have to sort of fix all this stuff. So again, the sheet connection that we're referencing is called tangent line, so I might as well replace that everywhere. And now we need to remember what we called all these values. So we should see them as slope 1 and slope 2. So we got slope 2. And here we have intercept 1 or intercept 2. And same thing here. And they're all capitalized. I'm actually not sure if it's case sensitive. Maybe we can run a quick test. So we have slope 1, intercept 1, slope 2, and intercept 2. Alrighty. At this stage, we should define, I guess it was N1 and N2. So how many tangent lines do we have? So I'll go ahead and just put this sort of here for each one. So here we have 7 tangent lines, and again we can label this num tan 1, and here we also have 7 lines, so I'll call this num tan 2. Okay. So going back to Cplex, we now know where to look. Num tan 1. And num tan 2. Okay, so this gives us n1 and n2. All right, so with that, we should be good to go. We're loading in all the values. All right, we're creating our ranges. And we are all set. Okay. So at this point, I'm going to change my default run configuration to be configuration 2. So I'll set this as default. And I'll run this guy. So let's see what ends up happening. Oops. It did not like something. Oh, no, there it goes. Oh, what did it run? Weird. Run configuration 2. Oh, Excel range unknown. So it did not like one of these Excel ranges. Okay. Oh, numtan1. So apparently I didn't label it correctly. So let's go back. Numtan1. Numtan1. Oops. Oh, and this should be numtan2. Numtan2. Numtan1. That's weird. I'm wondering if it's actually getting it incorrect. Let's try that again. What did I do wrong? All right, I'm going to pause to figure out what my mistake was real fast, because it should be working. Okay, I feel silly. I was working with the original version that was on my desktop, not the version that was in the workspace. So let's open this back up, and we will label things correctly. The other things that I changed is I spelled tangent wrong here, so went ahead and corrected that. Okay, so let's get this right this time. So n is equal to 7, and we are calling the cell numtan1. Okay. Oh, or numtan2, sorry. Oh, did I label these things wrong? Can I delete a label? Oh, it doesn't like the fact that I had labeled this before. Okay, so let's do this. Find name. Okay, so this might happen to you if you accidentally label something wrong. How do you relabel it and delete the original label? So you can see I accidentally labeled the number of lines numtan1 on sheet 2, and the number of lines for the first tangent line numtan2. So I sort of swapped them. And so I actually want to correct this issue. All right, so how can we do this? So I'm going to pause for a quick second to figure out what I need to do to correct.
Okay, so I figured out how we can correct this. If you click on the Formulas tab, there's something called the Name Manager. So you can click there, and you can see here it has all the named labels for the cells. Now, you could probably go about fixing this two different ways. You could either delete them. So let's say you created some that you didn't like. You could go ahead and delete them. But in our case, we just flipped them, so we might as well correct them. So that should be pretty easy. So we can go into the... We can go into here and actually edit it. So I'm going to type in F1. All right. And for numTan2, I want to replace this to F2. Okay, so there we go. Now we're all set. And now we can save it and head back into Cplex. And at this stage, we should have everything set up appropriately. Hopefully I got it all right. I'm going to run it. So run configuration 2. And there we go. So we got our B's in there, our N's, and it actually ended up solving for X1 and X2 as we expected. All right. So one of the neat things that we can do is, let's say we created a bunch of tangent lines, but we didn't want to use them all. So let's say we didn't want to use this tangent line here. There's actually a few ways that we could do this. One of the ways is, let's say we don't want to use the fourth one. All right. So in this loop here, so let's say we don't want to use the fourth one, we can write a condition. So this is like a such that, and we're going to write a such that C line is not equal to T, or C line not equal to 4. Okay. So now what you'll see is it will generate all the constraints and solve the problem excluding the fourth line, the fourth tangent line. Okay, so let's see. We're going to do that. We might get something different. Might not. There's a neat little thing that we can do. We end up, I think we get the same answer there. But either way, this is a fun little trick that if we want to exclude some lines, we can certainly do that. Another sort of trick that we can do is we can define a set. The way we define a set is we sort of use these curly braces, we give it the type, and then we define the variable name. So maybe we'll call it partial lines. Okay, so we're not going to use all the lines. It's a partial set of lines. So, you know, before we were using 1, 2, 3, 4, 5, 6, 7. So the 7 tangent lines. But let's say I wanted to only use, you know, tangent lines 2, 5, and 6. I could certainly do that, right? And we can do that by setting up this set of tangent lines. Now, what we'll do is in the for loop for creating the tangent lines for the second function, instead of using the range, use lines 2, we're going to use partial lines 2. And again, that's only going to use the tangent lines 2, 5, and 6. So if we go to our Excel spreadsheet, that's just basically using this tangent line here, and then these two tangent lines here. So let's see what happens. So we can go ahead and save that and run. Again, this is a little bit of a silly problem, so we might get the exact same answer, or it might change. Oh, you can actually see it changed here. All right. So these are fun little games that we can play with these for loops. So hopefully you've learned something. I had to cut the video short because I'm running out of time on my recording. So this is a good example problem to help you with your homework.